Good afternoon everyone. This is the fourth chapter, Q. In this chapter first we will see the introduction part. Yesterday I taught you about the stack. Stack is your LIFO, that is last in first out principle. In this chapter we will learn about another data structure called as queue. Queue is basically first in first out. Whatever we will put at first time, that we will pop at the same time. Okay, when we are going to pop something from the queue. Okay, so that will be your first in first out principle. Queue is an order linear list element having different ends for adding and removing elements in it. Okay, we are adding something and we are removing something, that is push and pop only. Okay, so examples of queue in our everyday life include students standing in a queue for morning assembly, right? This is one of the examples. Then customer forming a queue at a bank, cash counter in a bank. Okay, this is one of the example of what? Queue. Then vehicles queue at fuel pump. This is also one another example of queue. Then petrol pump, this is the queue of cars in a petrol pump. Okay, then we will see what is first in first out principle, that is FIFO. Okay, the element that has been longest in a queue will be removed first. Okay, that principle you have to remember, that the element has been longest in the queue will be removed first. It is also known as the first come first serve approach. Okay, queue is an arrangement in which new object atom always get added at one end, usually called rear, and objects atom always get removed from the other end. Okay, means what? Always get added at one end, usually called the rear, and object atoms always get removed from the another end. Okay, means whatever we are pushing something at first time, that will be removed when we have to remove that element from your queue. Okay, that is your first come first serve approach. Okay, so that is called as front of the queue, and rear is also known as tail and front as head of the queue. Okay, that we will see in detail. Then application of queue. The concept of queue has many applications in real life. Okay, if a train ticket is in the waiting list, okay, if the train ticket is in the waiting list, it means the ticket is in a queue of tickets waiting to get confirmed. Okay, so that is the RAC ka concept. Okay, already I think already you know this RAC ka concept, means it is a waiting list as per the increasing order of waiting numbers. Okay, right? So if a confirmed ticket is cancelled, the WLI number ticket is removed from the front of waiting queue and confirmed. Okay, so it is removed from front of waiting list queue, and that will be and confirmed. Okay, so that ticket will be removing of front of the queue and confirmed. Okay, sometimes on calling a customer service center, the interactive voice response system tells us to wait till a support person is available. Okay, at the time of the calling center, the support person will be available. Here the call is put into a queue of customer waiting to be serviced. Okay, if we are waiting for a service, that call has been waiting for what? To be serviced. Okay, queue of customers waiting to be serviced. Okay, that is only at the bank also, and at the petrol pump also. And what else I taught you about the students standing in the queue for morning assembly. So these are the different types of the first in first out, or we can say first come first serve principle for queue only. So you can say like that, if the queue of customers are waiting in the call center to be serviced. Okay, now imagine there is a single lane one-way road, then the vehicle that entered first will exit first. Okay, imagine there is a single lane one-way road. If we have single lane one-way road, then the vehicle that entered first will exit first. Whatever vehicle come first, that will exit first, following concept of queue. Okay, that is FIFO, or we can say first come first serve, that is FCFS. Then likewise, vehicles in a highway toll tax both the serve following the principle of FIFO. They are following the principle of FIFO, so we can say that these are the application of queue. Then the second part, following are some examples of application of queue in the computer science. Now we will see the example. These are the examples of real life. Okay, that is application of real life. Now these are the examples of what application queue in the computer science. Suppose there is a web server hosting a website to declare result. This server can handle a maximum of 50 concurrent requests to view the result. If we have web server hosting a website to declare result, okay, we have different websites and that will be displayed on the web server to declare the result. This server can handle a maximum of 50 concurrent requests to view the result. Okay, so to be served thousands of user requests, a queue would be the most appropriate data structure to use. For that purpose, we are using the queue for the user request. Okay, and that will be most appropriate data structure to be used. This is one of the example of the queue in the computer science. Okay, the next example is what some operating system are required to handle multiple tasks called job seeking to use the processor. Okay, over here we have different job seekers. Okay, so but we know that processor can handle only one task at a time. In the operating system we have different job seekers. Okay, and that multiple tasks are to be able to complete by using the processor. So if we use one of the processor, at that time only one task will be used. Therefore, in a multitasking operating system, jobs are lined up, queued, and then given access to the processor according to some order. Okay, so what will happen if we are using multitasking operating system? The queue at the time jobs are lined up and then given access to the processor according to the some order. Okay, according to the some order, that multitasking will be happen one by one. Okay, the simplest way to give access to the processor on FIFO basis, that is according to the order in which jobs arrive with a request for the processor. The simplest way is to give access to the processor on a FIFO basis. On the FIFO basis, what will happen, that is according to the order in which the jobs arrive will request to the processor. The jobs arrive in the operating system that will request to the processor according to the FIFO ka concept. Okay, when we send print commands from multiple files from the same computer or from different computer using a shared printer. Okay, when we send print commands from multiple files, if we are sending print command for the multiple files from the same computer or from the different computer using a shared printer, the operating system puts this print request to the queue and send them to the printer one by one on FIFO basis. Okay, on the FIFO basis only, if we have multiple files on the single printer, or we can say on same computer or different computer, by using the shared printer, we are requesting that particular print request in the queue and then send it to the printer one by one on the FIFO basis. Okay, now next one is what? Operations on queue. First we will learn about the enqueue. Is used to insert a new element to the queue at the rear end. Okay, we insert the new element to the queue. We insert the new element to the queue at the rear end. Okay, we can insert elements in the queue till there is a space in the queue for adding more elements. Inserting elements beyond capacity of queue will result in exception known as overflow. Okay, if we are entering element multiple times in the FIFO system in a queue, that will be throwing an exception as the overflow. Okay, so this is NQ. Because of that, it is NQ because we are putting elements and elements one after the another in the queue, so that will throw an exception, right? Overflow. Then DQ is what is remove an element at a time from the front of the queue. Okay, NQ is rear end and DQ is your front of the queue. Now I already taught you about rear end and the front end. What is rear end? Queue is an arrangement in which new objects atoms always get added at the end. Okay, you can see over here, this is the rear and front end ka concept. Queue is an arrangement in which new objects atoms are get added to the one end, usually called as rear end. Okay, any end if we are adding something, that is called as a rear end, and object atom always get removed from the another end, called as front end of the queue. Okay, that is rear is your tail and front end is your head of the queue. Understood? Now operations. In operations I already taught you about NQ. Okay, now we will see DQ. DQ is what? Your front of the queue, means your head of the queue. Okay, in NQ what happens? This is the rear end. So in rear end already I tell you about the rear end, that is get removed from the another end. Okay, so that's why it is your NQ. If we are putting elements one after the another, obviously it will be removed from the queue. So DQ is what? If we are using DQ is your front of the queue. We can delete elements from the queue until it is empty. Okay, until it is empty, we can delete elements from the queue until it is empty. Trying to delete an element from an empty queue will result an exception, that is underflow. Okay, understood? DQ is also if we want to remove something, if the queue is not empty, then only we can remove something. So if you are trying to delete an element from the empty queue, that will result to show an exception like underflow. Okay, so to perform NQ and DQ efficiently on a queue, following operations are also required. First one is your is empty. Used to check whether the queue has any elements or not. Okay, here we have to check there is any element or not, so as to avoid underflow exception while performing DQ operation. Over here is empty. We have to find out whether the queue is empty or not. That's why it is DQ operation which throws an exception like underflow. So by using is empty, we can avoid the underflow exception while performing the DQ operation. Okay, now next one is peek. Used to view elements at the front of the queue without removing it from the queue. Okay, used to view elements at the front of the queue without removing it from the queue. Pick means what? Used to view the elements at the front of the queue. Over here only we are using front. So in front what happens? We are removing the element whichever comes first. Okay, so used to view the front of the queue without removing it from the queue. Okay, so pick is basically used to not to remove the element from the queue. Okay, and without removing it from the queue. Front is what and rear is what I already taught you. That rear is your head and front is your tail. So pick is basically useful to avoid removing the elements from the queue. Okay, now is full. Used to check whether any more elements can be added to queue or not. That we have to check to avoid overflow exceptions while performing NQ operation. Used to check whether any more elements can be added to the queue or not, to avoid overflow exceptions while performing NQ operations. Okay, so what will happen? Is full is what used to check whether any more elements can be added to the queue or not. That we have to check to avoid overflow exception while performing NQ operation. Okay, so we have to check that overflow should be avoided, and then NQ operation will be performed. That is full. Over here just we have to check the queue is full or not. Okay, and we have to avoid the overflow exception while performing NQ operation. Then this is the figure over here, shows the various stages of simple queue containing alphabets. These are the different alphabets over there in the figure. Front of queue is on the left and rear on the right. Okay, so operation perform. NQ operation over here we are performing. What is NQ? I already taught you that NQ is what known as overflow. Inserting elements beyond capacity of queue will result in an exception. Look at here, this is NQ. Inserting elements beyond capacity of the queue will result in an exception. Okay, that is NQ. That is overflow. Overflow we have to remember. So this NQ, Z, front and rear. Okay, front is what? Front is your head, and rear is your front is your tail and rear is your head. Okay, and we are this Q is basically from the right hand side of your bucket. Okay, so this is your NQZ, then NQX, again it is at the rear. So it is NQ, not Q. Okay, so that you have to remember. Just you have to remember that should be various stages of stack operation. Then again C will be inserted, then DQ. Z will be at that DQ will remove from the DQ will be removed from what? DQ will be removed from the front side. Okay, that is your tail. Okay, then again DQ will be here. We are NQing V again, then DQ, again X will be removed, then again DQ, C will be removed. It is not Q, it is NQ and it is DQ. So we have to enter the element at the rear side. Okay, that is your head over there. Okay, so DQ is what? We are removing something from the tail. Okay, that is your front side. That is various stages of stack operation. Implementation of Q in the Python. Now what will happen? There are many ways in which queues can be implemented in a computer program. One way is using the list data of the list data type of Python. For creating a queue structure in the program, following functions need to be defined. Let's create a queue named myQueue. We can create it by assigning an empty list. myQueue and list is empty. Okay, a function NQ to insert a new element at the end of the queue. Okay, NQ means what? We are inserting the element at the end of the queue. The function has two parameters, name of the queue and element which is to be inserted in the queue. So def NQ, def keyword we are using in the Python, then NQ we are using, after that myQueue comma element, then myQueue dot append element. Append means we are adding something at the end of the list, that is the rear, that is your head in the queue. Okay, so we don't need to implement is full. Okay, is full, there is no need to implement is full, as Python being a dynamic language does not ask for the creation of list having fixed size. Hence we will never encounter a situation when the queue is full. Okay, then that is full, there is no need to write is full, because is full is basically useful for what? IsFull is basically used to check whether more elements can be added to the queue or not, so it avoids overflow. Okay, so there is no need to check overflow because we are adding the elements. We have already some of the elements also. If we have to text the input that is according to our requirement, and then we are appending something, so there is no need to use isFull. Then if function isEmpty is to check if a queue has an element or not. This can be done by checking the length of the queue. Okay, we have to check the length of the queue over here. The function has a parameter name of the queue and returns true if the queue is empty, false otherwise. So def isEmpty myQueue, if length myQueue equals to 0, return true, else return false. Okay, that you have to check from the isEmpty, that the length is 0, then it will return true, else it will go to false. Then dequeue to delete an element from the front of the queue. Okay, a function dequeue to delete an element from the front of the queue. It has one parameter name of the queue and returns deleted element. Okay, the function first check if the queue is empty or not for successful deletion. Okay, dequeue already I taught you about dequeue, that it is remove the element from the front of the queue, that is your tell. Okay, so this is your dequeue, def dequeue myQueue, if not isEmpty myQueue, return myQueue.pop, then else print queue is empty. Okay, we have to pop the elements one by one. If not isEmpty myQueue, then we are returning to pop. Okay, we are removing the element at the 0th position. Okay, and else it will go to queue is empty. Okay, understood? The pop function with index 0 will delete an element from the beginning of the list, hence front of the queue. Okay, that is front only, that is your tell. Then function size, to get the number of elements in the queue, we can use the length function of Python's list to find the number of elements in a queue. Okay, we have to find the number of elements in a queue. For that purpose we are just using size myQueue, then return length of myQueue. Okay, so over here we have this one of the example, that is a function pick is simply read but not delete the element at the front end of the queue. Okay, so def pick myQueue, if isEmpty myQueue, print queue is empty, return none, else return myQueue 0. Okay, pick means what? We have to read something but not to delete from the front element at the front end of the queue. Def pick myQueue, def pick myQueue is if isEmpty myQueue, print queue is empty, return none. Okay, so just we have to read myQueue. Is it is empty, then we are just going to print queue is empty, otherwise it will return none, and else it will go to return myQueue, that we have to return the myQueue at the index 0th position. Okay, so this is pick one. Now next one is what? Let us consider the example of queue that people form while waiting at the bank cash counter. Usually following are the events that occur in a queue. Okay, so these are the examples of queue that the people form while waiting at the bank cash counter. Okay, that examples I'm going to explain you. So over here what you have to remember, two friends come together and get to the cash counter. Okay, they form a queue, right? And NQ operation is performed 2 times. Okay, then as soon as the person at the front is serviced, he will be removed from the queue. Okay, as soon as the person is at the front of the service, okay, one person done his service, then it will be removed from the queue, thus the DQ operation is performed. Then the cashier calls next to the serve the next person will who is now at the front of the queue. So cashier calls the next serve and then perform again the queuing operation, front of queue operation. Then cashier wants to know the length of the queue, that is size of queue is checked. Cashier wants to know the length of the queue, that is size of the queue should be checked. Then meanwhile a few more people walk in the bank and three of them join the queue at the cash counter. Again what happens, three of the people join the cash counter, so the NQ happens three times. Okay, another person gets served and leaves the counter, again DQ will be performed. Then cashier calls the next to serve and another, again next to serve will be there, so the next three people get served one after the another, so the DQ is performed thrice. Okay, then cashier calls next and realizes that there are no more people and to be served, that is underflow situation of happens, right? So now let us write this code. Let's write this code practically, so you will get to know the answers of these examples practically. So first my queue list will be there. Okay, list method will be there, each person to be assigned a code as P1, P2, P3. Okay, then element input, enter person code to enter in the queue. Then NQ will be happen, my queue comma element. Okay, my queue comma element will be there. Okay, then element input, enter person code for insertion in the queue. Okay, then NQ my queue comma element. Then print person removed from the queue is DQ my queue. Person removed from the queue is DQ my queue. Okay, DQ will be performed. Okay, we are removing the element. Again number of people in the queue is size of people. Okay, then element number, enter the person's code to enter the queue. Then NQ my queue element, again we have how much we have, 3 we have. Firstly we enter, again we are entering the code for the insertion, again we are removing it, again we are calculating the size, again we are entering something to the queue, again we are entering something to the queue, again we are entering something to the queue 3 times. Okay, then print, now we are going to remove remaining people from the queue. Okay, that we have to remove. So what will happen, while not is empty my queue, not is empty my queue means it is empty, so print person removed from the queue is DQ my queue. Okay, so output is what, enter person's code to be the first, P1 we have, P2 we have, so P1 will be removed, so number of people in the queue is 1 only. Okay, that you have to write. Then person again code P3 will be there, P4 will be there, P5 will be there. Now we are going to remove remaining people from the queue. So how much will be there, P2 will be there, P3 will be there, P4 will be there, P5 will be there. Now queue is empty. Finally we are removing everything from the queue. So while not empty, person removed from the queue, DQ my empty. So queue is empty. Okay, we are doing DQ operation. Okay, we are performing DQ operation on the my queue, that's why the queue is empty. Now introduction to DQ. DQ pronounced as DEC is an arrangement in which addition and removal of elements can happen from the end, that is head, front or tail, rear. Okay, this is data structure does not apply any restriction on the side of which addition, removal of elements should happen. So it can be used to implement stack or queue in the program. So over here what happened, DEC will be the arrangement in which addition and removal of elements can happen at the end. okay, at the head or at the tail. So this data structure does not apply any restriction on the side from which addition or removal of element should be happen. Okay, so it can be used to implement stack or queue in the program. Okay, it is also known as double-ended queue because it permits insertion deletion operation by the end. Okay, so over here we are just call it as deck. We are performing deletion operation, that is removal of element from the end, that is your head or tail, that you have to remember. This data structure does not apply any restriction on the side of which addition or removal element should be happen. Okay, addition and deletion happens in this case, so they does not apply any restriction on that, so it can be used to implement stack or queue in the program. Okay, it is stack, otherwise it is queue. So it is also known as double-ended queue because it performs insertion deletion operation at the end. So let's see if it is insertion, that is from front side, that is your head, that is what? So this is DQ. Okay, so over here let's see, they have already mentioned the front, they have already mentioned the front and the tail also, that is rear and tail. So rear is also known as tail and front is your head. Okay, so that you have to remember. Rear is also known as tail. Rear is your tail and front is your head of the queue. Okay, that you have to remember. I thought I maybe inverse something by mistakenly, so you have to remember this, that front is what? Front is your head and rear is your tail. Okay, front is your head and rear is your tail. So we are pushing insertion over here and popping something, that is deletion. Again pushing insertion and popping something at the deletion. Okay, basic DQ structure displaying head and tail to implement stack or queue. Say basic DQ structure displaying head and tail to implement stack or queue. So this is DQ operation. Just you have to remember what is front and what is rear over here. So you have to just remember that what is front. Front is your head and rear is your tail. So DQ is your desk. This is the basic structure you have to remember. That pushes insertion, pop is deletion from front side, and from rear side again pushes insertion and pop is deletion. Okay, then application of DQ, that we will see in the next lecture. Okay, application of DQ. So I thought by mistakenly I taught something wrong about DQ and NQ, so just you have to inverse it. DQ, front and tail, you have to just remember front is your head and tail is your rear. Front is your head and tail is your rear. Okay, right? That you have to remember. Rear is what? Tail, and front is your head. So this I thought by mistakenly opposite one. So NQ is what? Z. This is Z. Front is your head. So NQing we are doing over here. So it is at the tail one. Again we are adding at the tail at the rear case. Okay, because we are using NQing. Okay, NQing means what? It is used to insert the new element to the queue at the rear end. At rear end we are entering something. Okay, at the rear end we are entering now, so it is entering. Just you have to remember this one, that rear is your tail and front is your head. Okay, sorry for that. I thought maybe it is just for this case only, not for other case. Okay, thank you so much for this lecture. If you have any doubt regarding this, you can ask me. Thank you so much.